Well, hey there, kiddos. We are going to talk about interpreting exponential functions. This should be a pretty quick video. Make sure you have your calculator out so you can follow along. Question 1. So a scientist conducting an experiment with an antibiotic on a colony of bacteria. It kills 2% every hour, and so here's your equation. And hopefully you recognize that as a decay function, because they did 1 minus the rate, which was 2%. That's how they got it. And I'm going to use my calculator. So I'm going to go over here. So here in my calculator, I've typed in my function, and I'm just going to go look at my table, and I'm going to go second graph, and so I'm going to look at my table and see what happens. So the first thing it asked was about 8, I'm pretty sure. It says how many will be left in 8 hours. So right here in my calculator at 8 hours, this is how many are left, so I'm going to write that number down. It was 850,763. And then it asks how many are left in 24 hours. So again, I go back over here to my calculator, and I'm going to scroll down to 24 now. And you'll see that this is how many I have left, 615,780. So I have 615,780. Now it wants to know how long it will be before I have half of the beginning amount. Well, I started with 1,000,000. Half of that would be 500,000. And so I have to go to my calculator and see, where do I have 500,000? And so you should see now right here, I have at 34 hours, I have 503,000. At 35 hours, I have 493. Well, they want to have half. This is more than half, so I'm going to say about 35 days. So it's an estimate. It'd take about 35 days. Sorry, hours. We're doing hours, not days. So there's that question. I used my calculator for all of it. So number 2, you have a chart that shows the ticket sales for movies on 2 different screens at one theater over 4 days. We're supposed to select the answer for each one. So we're going to, based on this table, what's happening. So the first one wants to know what kind of model best describes the ticket sales for screen 1. Well, if we just look at screen 1, here's what's happening. This is increasing by 40. This is increasing by 40. This is increasing by 40. So it is going up by the same amount every time, which gives me a constant rate of change, which makes this linear. So it's going to be a linear function for screen 1. Now they want to know which one describes the data for screen 1. Well, I know it's a linear function, so this one's automatically not it, because that's quadratic, and it's automatically not this one because that's exponential, so it's one of these two. So what I have to do is figure out, before I can write my equation, where 0 would be. Well, if I'm adding 40 every time to get to 0, I subtract 40. This would be 360. So I would start at 360, add 40 every time. This would be my equation. You could also use your calculator. So you go over here and you could go to Stat and Edit. And then in list 1, we would put those x values, which were 1, 2, 3, 4 for the days. So I would go 1, 2, 3, 4. And then over here in list 2, I would put the number of movies. Which was increasing by 40 every time. So it was 400, then 440, then 480, and then 520. And since I know it's linear, I can go over here to Stat and calculate. And since I know it's linear, I can do option 4 and do a linear regression. And it will give me the equation, and it tells me that it is 40x plus 360, which is the one that we circled based on what we did. So now part C wants to know what kind of model best describes the screen 2. Well, on screen 2, let's just look at what's happening. From 3,000 to 2,400 is going to be minus 600. And then from 2,400 to 1920, well, that's not minus 600, so it's not going to be a linear function because it doesn't have a constant rate of change. So that part doesn't really matter. So here's what I really want to do. I'm going to put these numbers in and just look at it. Let's see what it looks like. So we'll go back over here. We'll go to Stat and Edit. And we're going to change our numbers for the first list. So it started with 3,000. It had 2,400. Then it was 1920. And then the last one was 1536. So we're going to change our window to make these numbers fit. I know that my Y max needs to be 3,000. So I'm going to go over here to my window. This is acceptable, but my Y minimum, based on my table, needs to be about 1,500. So my Y minimum, sorry, not my X minimum, my Y minimum. So go down here to Y minimum. We're going to make that 1,500, and then my Y maximum needs to be about 3,100. And we'll have this, my scale be hundreds this time to make everything fit. And we're going to go to second Y equals so we can do the stat plot. So we're going to turn that first plot on, and then we're going to graph it and see what it looks like. And so now I've graphed it, and when I look at it, they're decreasing because I know that's happening, and they're getting closer and closer together. And so what this tells me, number one, this is not going to be quadratic. And here's how I know it's not going to be quadratic, because there's people coming to watch a movie, and so it's not going to decrease, and then all of a sudden increase back up. Okay, because we're talking about the ticket sales on the movie. So on day 10 of the movie being out, there's not suddenly going to be that many more people watching it. So it's not going to decrease, and then turn around and increase like a quadratic function would do. And we know it's not linear because it doesn't have a constant rate of change, which tells me that it's probably going to be exponential because that's what we've been talking about. So now we're going to have to find the function. Well, I know it's not this because that's a linear function, and that's a quadratic function, so it's one of these two. So I'm going to go back to my calculator. I'm going to go stat and calc, and this time I want the exponential regression, which was 0. So I'm just going to press 0. I'm going to go down here to calculate. And so you should see, here's my equation. It tells me that my A is 3750 and my B is 0.8. So my function is going to be 3750 times 0.8 to the power of x. And if we look at our answers, this one is 3,000. That's not going to be it. So it's going to be this one that's going to be my exponential function. And I use my calculator for all of that. So the difference between linear and exponential, linear increases by a constant rate. Exponential is going to be multiplied by the same thing every time, and it looks like what we're multiplying by every time is 0.8. And I bet if you went to check it and you did times 0.8 and you did this times 0.8, those would be the numbers you came up with. And then quadratics, your second differences are going to be constant, but what you want to pay attention to with a quadratic is that your number, it's symmetrical, and so the numbers would go like 1, 2, 3, 4, and then 3, 2, 1. So the numbers would be they would repeat each other. So for number 3 here, last one. So in 1985, there were 285 cell phone subscribers in the small town of Centerville. The number of subscribers increased by 75% per year after 1985. First of all, what's the meaning of this y-intercept? This number right here. Well, it looks to me like that's about 285. So that was your starting number of cell phone subscribers. And I'm not going to write subscribers, I'm going to write users, same thing. Now in 1987, about how many subscribers were there? Well, if I started in 1985, that's at 0. Then years after 1985, 1987 is 2 years after. So here it is at 2 years, and it comes up and it meets the graph about right here. And so it looks like in 1987 there were about 900 cell phone users. So it increased a lot. Now for the range of this situation, we're looking at Y values. So we're looking at cell phone subscribers. Well, it started at 285. And then it increases forever. We don't have a stopping point. It's just going to get greater and greater and greater. We don't know where to end because this only goes to 11 years after 1985, but we're way past that now. So what we're going to say is that Y is all numbers greater than or equal to 285 because it starts at 285 and then just continues to get bigger. So that's exponential functions. We will practice that tomorrow. I will see you then.